text, yeah, but it does increase the amount of data.
Yes.
Okay,
So
I
it's
return the
so
speaker.
better
to
see
you.
the issue.
Oh, absolutely.
I don't want to miss a thing.
There should be plenty of stuff.
Yeah? No space?
And from a revolutionizing science is for some of us the holy grail of this stuff, but my assertion is that it will revolutionize science policy as well as science. And that may be a lower hanging fruit. Research.gov and NIH Explorer and Reporter and things like that.
And also, maybe one final remark, don't think this is all about scientific knowledge discovery, because think about an application being 3 UUIDs and having a thesaurus that knows the terms in all languages. Now you can expose that in human readable language in any language that was chosen by the person in his interface. And we were talking about this recently in a totally different context. I have a blind nephew, and there's a company here in Wisconsin called YCAP, and they have this glasses with a camera, and on your tongue you feel the image, and it translates into your visual cortex. It's a revolutionary technology.
Wonderful.
And I was wearing the glasses myself because we wanted to do a clinical trial in Holland, and you can see vague things, but based on your tongue, I couldn't do that. You had to be 2 weeks of training. But yeah, so anyway, they have a handheld which will now switch to a mobile phone, and I said, so if I see the bus stop, I can vaguely see where it is. If you have a QR code, and you can capture RDF and QR codes on the bus stop, you hold your phone next to it, it will tell you in your own language, this is a bus stop, and the next one will come in 5 minutes. And that can be encoded into nano applications, captured in the QR code, and read by an iPhone in any language.
And the practical applications are
Tremendous.
tremendous.
It's the way we think, so it's really mind-machine interaction, because you can at any time switch back to human readability, computer readability, and go back to MEDLINE, which is perfect.
Yeah, no, I have to comment as a transition from the Baron Straka now from Big. Yes, I'm very, I think it's very supportive of the idea, and I think it is, I totally agree that, and I read Ernie we were talking earlier about the, they call it the tsunami of information, and that really is what has to be done is you have to boil down the ideas underpinning that, and you wade through that space like I'm suggesting, and then you pick a few quality things that you actually read. And I think what I'm going to present is complementary in a couple ways, I think, to what Baron has presented in the nano publications. I mean, the one thing I understand, nano publications are so far largely done by hand, I assume. Is that right?
Yeah, well, the most difficult source to get them from is text.
Yeah.
Because text is written for humans.
Right.
But we also get them from the text. We have 6 taggers that try to do
Okay, with
a crippled way to
yes,
say the
okay,
thing you
yeah,
do.
yeah.
But obviously, my big incentive for today would be if we could take the 65 million highly qualified triples that you have and turn them into nano applications simply by adding the provenance in the context, we would have an extreme
Which of course
development.
is largely there because
Yeah.
it's from a metadata. So
But if you mine them, for example, from a Leiden open variation database, there's the color.
well, then of course,
then
yes,
it's so
then,
much
yeah,
easier.
yeah. Then of
So
course,
the most
they're
difficult
taken right
source
there.
is text.
Text,
Actually.
That's right. So I'm going to actually present an underlying technology, the natural language processing, which produces input to nano publications essentially, and I'm going to at the same time then give a sort of an alternative higher level implementation application for exploiting them that we have come up with, which is in some ways complementary, in some ways basically complementary what you showed there. So the thing is, I normally give this talk in the context of information retrieval systems, and it applies to what Baron is saying, because if you want to get nano publications from text, you probably might want to get text in some area that you're interested in to begin with. And for example, I mean, it could be done in Google. We've done it with PubMed. But I'd like to point out, is that the technology of information retrieval systems is, essentially hasn't moved since the 80s. They basically manipulate text strings with sometimes some level of more sophisticated frequency of occurrence or distribution patterns, but there's no access to anything like meaning. So So, I mean, this here is just kind of generalizing some of what Meredith was talking about, but with the emerging applications, which aren't used sort of generally by people on the street, but are in the academic world, all of these are studied quite assiduously. I mean, one, text mining, that's what Meredith was talking about, where you have some task-driven extraction of facts to observe trends, and particularly, the same, connecting text and structured data. You get it from the structured data, but connecting to text is not that easy. We need more sophisticated tools for this. And other things that are again hot topics in research, not available sort of readily. Automatic summarization that really does summarize. Question answering that can answer questions that professionals might have, not just what's the height of the tallest building or who's the president of X. And I think particularly, as Meredith was meant this, but didn't put it in this particular this kind of a research. Literature-based discovery, a particular paradigm for assisting researchers in the way they do work. So all of these require more effective language processing, I'm saying. And some of you may know something about this. There is another sort of avenue of more sophisticated natural language processing, statistically based, which I'm not going to talk about. For 20 years, I've been working on the semantic based, and so I'm going to stick with that. So the thing is, this augments document retrieval systems, or any kind of a retrieval system. I mean, it doesn't replace anything, it supplements. But it manipulates the information, not just the documents itself. So it doesn't just throw at you a bunch of documents saying, and then say, okay, you want them read? Well, no, that's not my job. You're on your own. So it bridges the gap, really, between the language, the text, and meaning. And then, I should say, it returns the meaning into computable form. They're essentially RDF triples that we have now, and you can then manipulate them. And this allows you to summarize and visualize information, which is one of the things I'm going to show you that the Semantic MEDLINE application does that. I'm also going to show you the underlying natural language processing technology that allows that to happen. So, Semantic MEDLINE, we'll start at the top. So right now, it is based on PubMed. You get PubMed search, you get Medline citations. You run SEMREP, which is the underlying natural language processing technology that actually extracts these triples. They have this exact same form. They're going to give you an excellent introduction to them. They have an argument, a predicate, and an argument, and all three of them are not just text. They're translated to the concepts in the MLS, as we'll see in a minute. So then you have these semantic predications, or these RDF triples. They're the same thing. We run automatic summarization on them, something developed in my group, well, not the generally automatic summarization, but a particularly effective kind of automatic summarization. And the results are displayed graphically, as you've been seeing plenty of this particular type of graph, which I think actually, this is now, we've been doing it a few years, but initially we got some flack about this, people saying, oh, just give a list, but I think almost anyone could rather see things connected than long lists paging through them. So and I point out here the ideas, enhanced access to biomedical literature, and supports biomedical research. So how does the underlying natural language processing, which we call SEMREP for semantic representation, work? So you give it text, any text, it doesn't really care, it'll do better if it's in the biomedical domain, but it will probably extract something from almost any text. So it goes sentence by sentence. Here, for example, exemestane after non-steroidal aromatase inhibitor for postmenopausal women with advanced breast cancer. What it does is extracts, here's the triple, the argument, subject, aromatase inhibitor, treats malignant neoplasm of breast. So and further I point out, these are both metathesaurus concepts, and Barry can point out, once you have done that, then you have kind of opened the door into a huge number of connections that you can make. So you really can take advantage of the meaning that concepts have in the metathesaurus or any ontology.
So what you actually store is the concept number from UMS?
Yes, we actually, strictly speaking, we actually give the CUI and we give the concept string itself too, just because so a human can look at it and it's more readable. But because we have a CUI, then you're totally baked into it. And I think it's important here that the semantic network relation also. This is not only is it a named relation, but it's a concept. So it's in the concept of the semantic network, which I'll point out in just a minute.
I'll tell you that I'm arguing, I can show you 20 emails with a guy working with Larry Hunter who says that I'm swearing in church saying that the predicate is a concept. Yeah, so there's still a big debate in the
I mean,
Semantic Web, but anyway.
Yes, no, that kind of, I mean,
So we agree, but not
yeah,
everybody
absolutely.
does.
Right, I mean, this is, you get into, I mean, you get too far out, but you get out into semantics, into entities versus processes and yada, but they're both essentially conceptualized. The big point is, it's not just a string of letters.
It's not, and we at least agree now, even with the Larry Hunter group, that each three of them should be unambiguously defined.
Mhm.
And that, for me, that makes it a concept.
Oh, yes, absolutely, and you'll see, I'll see in a minute, I'll show you a little bit about the UMLS, how we do that. Oh, that's an absolute essential, that in semantic representation, I mean semantic, not semantic web sense, but this sense of language sense, relationships must be unambiguous, that's absolutely right. I mean, that's the problem, my English is so hard to turn to me. Dog can mean, I mean, not just as a concept, but as a relation. I mean, you know, my debt collectors are dogging me to death. So, so the thing is, how does this kind of conceptually then work? So we sort of extract all these predications from a bunch of text, however much you send to it. And one thing I point out is that this just gives a flavor. There are 26 predicate types that we use so far, mostly from the UMLS. We've also enhanced it a bit. But you get things like treats, clinical domain, but also molecular biology, gene associated with disorder, gene stimulates gene. So we get a kind of a range of meanings. Another thing I point out here is that kind of not all predications are created alike. Barrett's pointed out something being repeated over and over, but many things repeated that you don't really need. I mean, you probably don't need to know if you're doing scientific research that tamoxifen treats patients. I mean, you know if it's a drug, that's what it does. So these lesser, I mean, we call the ones on top, are more informative. So what do we do with them? We actually have an abstraction summarization system developed by my colleague and has worked with me for 10 years, Marcelo Fishman, where we take the predications themselves, not the text, take the predications, and we reduce them to the salient predications, the ones that really are going to do you some good. And so far, with one system you specify a topic, although we have a statistically based system which we're just bringing out, which sort of looks at a bunch of text and decides for itself what the topic is. What is this text mostly talking about? So you retain predications on the topic using a schema, kind of a meta predications of saying I want all the ones that say drugs, relationship, disease, for example. Or you could say I want all the treats. I mean, you can generalize.
Basically, the Semantic Network of
Yes. All this stuff is, I mean, 100% compatible with Semantic Network. It's just that I have kind of developed it from the conceptual point of view, haven't implemented that way, although partly we also, my colleague Olivia Goldenreiter has turned not all of it, but many of our predications into an RDF triple store. But the rest of the stuff is you just drop it into the Semantic Web. It's made for the Semantic Web. You eliminate the uninformative predications by a trick we use just looking in the UMLS hierarchy. And if something is high in the hierarchy, then you have to get a cutoff. Empirically, it's too general, so you eliminate predications that say drugs do things or things happen to patients, that sort of thing.
Sorry to interrupt.
No,
but
that's
I
fine.
think
Please do.
because what I just showed very briefly, the end of the sawtooth, where we have this overrepresentation of certain predications, relationships, that we removed, was a totally sort of objective way of trying to find. We could compare that set with your set and see.
It's the same kind of thing, yeah. It's the same sort of thinking. There's probably various little sort of variations on how to do this, but they're kind of all cut from the same cloth and they have the same goal in mind. And they probably
Finding needles in the haystack.
Yes, I think that's right, sir. That's right. And we use, frequency has some importance. Not total, and you might not always want the most frequent predication. Sometimes you want the least frequent for discovery, but you need to sort of know something about it. So once you have done that, then we eliminate those. And the thing is, then moving from the NLP into the information management application, Semantic Network, what we do is, just like that, we turn this into a graph. And the thing is, that's kind of what this is an application. You can say, I'm only interested in this predication. And we maintain links to the text it was extracted from, so you can pull one up, and that's the one you can read. And then, as you do, then I sort of find out you do your thinking. I mean, so the point is, the computer doesn't do your thinking for you, but it's a tool. It makes you smarter, as it were. It facilitates your thinking. But it's just how much do you read? I read less now. What thoughts do I have? I have more sophisticated thoughts because I know more connections. That's the sort of thing I think we should think about this. I've written a paper just recently last year, and Amy, where I call this relationship between human and computer as being sort of cooperative reciprocity. I mean,
You call it mind machine.
yeah, that's
really
right.
nice.
But it's like
Yeah.
the two, you're working together as a team, as a pair.
Symbiosis.
Yes, that's exactly right, exactly. So now let's look a little bit at, I want to show you a little bit about the technology, it won't be too heavy duty, but just to give you some flavor of what the natural language processing does, and it gives you some idea for how feasible and how scalable is it.
So, I have a quick question.
Yes.
This is a really basic question. When you go from the text, sentence by sentence, and you pull out how do you identify the meta source concepts from that string?
Yeah, you know what, I'll show that when I go all the way through. There's a program that's called MetaMap.
Okay.
That goes, and this will become clear when I go through exactly how it works. So you first sort of identify noun phrases using purely syntactic techniques. Then you use a bunch of methods to say, okay, here's a noun phrase, and I'm only going to match noun phrases to concepts in the metathesaurus. And you have various things then you look at. How close is the match? Is the head involved? I mean, that is the most major part of the noun phrase. So red apples, apples is the head. Those kinds of things. I'll give you just a flavor of that in a minute.
You could run, for example, if you look for chemicals, you probably do different pre-processing.
Yes, that's exactly right. So the concept or entity identification, there's various techniques, and we use MetaMap because it was also developed a library. There's other methods that could be used. Graham's 100% right for particular kinds of chemicals. For us, for like genes, genes are very difficult to get right because of all the ambiguity. So we have a special processing that uses several techniques that use statistical methods, looking up in a dictionary, this sort of thing. So that's right. And it kind of goes along with, I think, with human cognition. There's two things to knowing something. Well, there's many things, but at the core, you sort of know the players, the actors, the things that are involved. And then the next question is, how do they relate to each other and interact? But you at least have to know that I'm talking about, coffee and tea rather than genes and protein. So they're separate in the system. So this is, there's some of the characteristics of this as a way, and I think some of these are the characteristics which make it feasible and not only feasible to do at all, but I think it's also robust enough. We've applied it to 21 million midline citations, and with a little better equipment and machinery, we could be processing the web on the fly. But not so much the equipment isn't there, but I just don't have it in my research for that. So one thing is we have to abstract away from full interpretation. There is no possible way any program you write today is going to interpret everything in a sentence that a human is just absolutely impossible. So you have to use, and even at the syntactic level, no possible way. You have to get the core syntax that is really the core aspect of what you need, not the niceties and the flourishes that we as humans can put on, largely not. We don't need them to get across our message, but it's basically to impress people. Because really what syntax is for.
To at least entertain.
Both. Right, if I were to sit here and and use bad grammar, your assessment of me would plummet.
That's what my wife says.
But I mean, in a simple case, if I were to sit here and say, oh, just between you and I, you would immediately, in this crowd, you would say, oh, I'm not so sure how much, he's supposed to have a PhD in linguistics, how much does he know? So this thing, but anyway, the computer doesn't make those niceties, differences. And we also limit to core semantic predicates and predicate relationships. That is, so in this case, I mean, we do treats, prevents, has location, a few like that, but certainly not all the range of everything that's actually asserted. And we focus the interpretation by domain. I mean, the domain has to be known, and it is biomedicine, biomedical research essentially. But if you were to give it something on economics right now, it wouldn't know it at all.
No, but if you would take ChemSpider, 25 million chemicals with
Yeah,
all
no,
their
I think
synonyms,
I think that's right.
Some reprocessing, you could
Yeah,
do
and I will give some. When I don't actually have examples in this talk, but I'll give sort of the indication that we have what we call domain migration. We've migrated the system away from sort of biomedicine. I talked about, I had a student who migrated to education and policy for policymakers of childhood education. And you just have to have the ontology, you have to have the concepts, you have to have the relationships, but the syntax, the English still remains the same. So it's a quite doable thing to migrate to new domains. An important thing I point out here, probably not so much that this audience necessarily cares, but I mean, you really need to do something like this in a principled way. This is not done just for expediency. I've been working on it for 20 years, and it's guided by linguistic principles. The point is, English has a certain structure, and all languages do, but we're doing English, so we exploit that structure, and you don't just ignore that just because it's hard or you don't like verbs and nouns and grammar. You have to face it, and you have to do that. That's part of the job. You have to accommodate incremental development. You can't sit down and expect to process every structure and every possible assertion type on day one. You have to start and build up, and you have to think about it and do ones that will do structures that will simple and will support more complicated structures later on. And importantly enough, if we're getting to exploit the structured domain knowledge, you need that. Ontological knowledge may be called, if you get into people arguing this in ontology, but it basically has concepts and relations in the unified medical language system. So I point out just a few of UMS's characteristics. One thing that it has that I'm not going to talk about is the specialist lexicon, which gives you purely syntactic information for almost 500,000 entries, and this is crucial because you need to know that plurals and singulars mean the same things. This verb can take a simple object or no object at all, but nobody but linguists wants to hear about those details, I'm sure. But we do have it and we use it. So the Metathesaurus, as we've been saying, this is maybe a little bit old. It may have closer to 3 million concepts now, containing variant terms and synonymous meanings. It's largely, its focus is biomedicine, but surprisingly enough, it has much outside of that. Geographic terms, it has just about everything you can imagine. Other things that have to do, you don't think of as a medicine, but sociological kinds of things. Social class, occupations and disciplines that are sort of, it has a lot. And crucially, these concepts are assigned one or more semantic type or semantic class. So this allows you to know whether something is a disease or a drug before you even know anything else about it, which I think is another big thing that humans can do. You might say, well, I'm not too sure exactly what this gene does, but I know it's a gene, or I know it's a protein, and I'm not exactly sure what's the difference between a protein and an enzyme, but I know there is a difference. So I think we can do a lot with this generalized information. And then, crucially, the semantic network takes those semantic types, and we'll see in just a minute some of them, and it organizes them into relationships, like treats associated with the process of. And this is, I think, is crucial.
The 54 relationships are at the semantic type level, so say drug may treat disease.
Yes,
and
exactly.
every non-application you find is an
That's right, exactly. They're at that level, so that they're more, and they can be generalized even more because they're in a hierarchy. So they're actually stated now just for implementation reasons at the lowest level, but as we'll see in a minute, it could be said though like I don't know what we could say. Substance treats pathologic function, let's say, which is parents of drug and disease. So.
But it's amazing to me that you have 50 rather than 500 or 5,000, and it's still efficacious.
Yeah, that's right. And we actually only use 26 of those. And surprising that, you can tell a lot even from that.
But that is what you.
But if you think about it, you can kind of boil down what is medicine. All medicine is basically either drugs or procedures treat diseases. There's one relationship. Patients get diseases, and sort of medical profession uses drugs and diseases. Basically, everything else is probably a children of that some concept.
George, this is also one of these things about triples. If you find the subject and the object, the number of potential predicates.
Yes, that's right.
Exactly. Very restricted. Very
Exactly.
So that makes it a lot easier than people.
Exactly right. So here is this is schematic, but this is kind of what the semantic network is like. So the predicates, the relations, are organized here structurally into physically types, inside of. Why you have the spatial one? I forget, physical next to sort of thing. Temporal, before, after, conceptually. I don't have examples of all these, but then the functionally ones are the big ones. So we get effects, brings about, let's say, occurs in. effects, and then we have both prevents and treats. We have a treats relationship. It joins these semantic types at the lowest level, which are in this hierarchy. I mean, health, therapeutic preventive procedure is a healthcare activity, which is an occupational activity. This is a pathologic function, which is a biologic function. So you could make generalizations at any of these levels. And this gives you an overview, I would say, of not the truth, but what we consider to be, how we consider the, kind of how, what.
Our model of the truth.
That's right, our model of the truth, exactly. So, and there's a lot of, this just gives you an overview, Baron, of the semantic network relationships. I mean, there's hundreds of these, but this sort of thing, disease or syndrome, process of organism, that's the getting it, I have it, occurs in population group, the epidemiology. So we take advantage of these. So so then I say, okay, what does SEMrup really do? So it concentrates on what are often called propositions. I mean, so this is like the function of a triple. So here, imipramine treats kind of is a triple, but what kind of a triple it is it's something I assert, or it's something that could be true or false. We don't concentrate on these higher level predicates that are some attitudinal, subjectivity, discourse relationships. No, the results provide strong evidence that. So far, SEMrup doesn't do that. Although I pointed out earlier, I have a person who has worked with me also for 10 years named Khalil Kilichoglu, who is just finishing up a PhD in computer science where he's addressing exactly that, and he has actually implemented this to a large extent, and we are going to put it on top of SEMrup, so that at some point these attitudes, whether this is something which has just been tried or asserted or discounted, will actually be available and will focus.
You can decode that in animation. There is a beautiful
Yes.
presentation of Anita Bart. She shows that Phil Bourne makes a paper, says these results may indicate
Exactly.
that, and it's carefully hatched.
Yes.
And then she followed that paper over 10 years,
Yeah.
and it got cited 20 times.
Yeah.
There's no further scientific evidence
Exactly.
ever. And the
Exactly.
last citation says, as we all know.
That's right.
this gene.
Exactly.
So this happens in the literature. So
That's
even
right.
if you find this thing,
Yeah.
we want to be able to trace back whether there's any further evidence that people are just repeating each other, and
That's
then
right.
it becomes the canonical truth.
And you will have a mechanism for manipulating that, but we will have the way of extracting that
Exactly.
from
So
the.
in combination, you could track this back and say,
Yeah.
if you cite this thing, did you
That's
create
right.
any further scientific evidence, or is it
That's
just,
right. That's right.
legal
Or
exposure.
or they'll simply say, it may indicate, or they'll just say, this study, attempts to determine. That's where they start off. They never say anything whether the study did or didn't determine.
But before you know it, people cite that.
That's right.
In the classical literature,
That's
there's clear
right.
examples.
That's
It becomes truth.
That's right. So this is an also indication what I mean by incremental development. So just getting the proposition to say it all is hard enough. But then we have that now, and now we go this we're hoping to go this next level of adding a pretty important level.
Isn't there a term or concept in the semantic web space that talks about this? Not objectifying, but what is it, where you can refer to a tuple, a concept that.
Oh, well, I think that's
Asserts a tuple.
reification, so that's
Reification, that's the
reification,
term I was
yes, which is
Is this related, is this
Uh,
reification or not?
Not exactly, although I would say, well, it's not that it's not related, no, it is related. This goes beyond that, so in order, I think, the point is, yeah, it is related in a way. So when you have reified a predication, then you can use that as an argument of some other predication. So these
And then you use
these
it for
higher
these
level
purposes.
ones, yes, yeah, that is right, yeah. So it's the difference between, I know Mary and I know Mary likes Bill. So the thing is, if I reify Mary likes Bill, then it becomes the same kind of thing as Mary, and then I can refer to either one of them as the object. So that is right, yeah. In linguistics, we call that predicational argumentation, so it's the same thing.
That's to confuse the public.
We don't dare let them know.
Make it sound like
They know what we're doing, yeah, that's right. So I won't hover on this slide. I just want to point out there have been others that have gone before me, doing this kind of work in biomedicine. The two big ones to point out here, Carol Friedman with MEDLINE project, which is slightly different, but it does as much the same spirit. It emphasizes clinical text, and it's like the biggie that is out there, the really sophisticated one. I point out Udo Hahn from I forget, he's in Germany, but with his But Syndicat and is a system also based heavily on linguistics and knowledge, like SEMREP. It hasn't gone quite as far because Udo it does not want to sort of abstract away from details. He wants to capture every detail, and it's difficult to do that. But it's very,
Very stiff.
But all new entities.
but it's a very big, very good work, very pioneering work in the late '70s already. He was talking about this kind of thing, and so it's very seminal. So we're going to go through a quick processing overview. So the syntactic analysis first, not worrying too much about it, but we go to the lexicon. We eliminate ambiguities like I said about dog. Is this a mammal or is it a verb? So is it a noun or a verb? Underspecified parser does this. This is what finds us the noun phrases. We'll see an example. Then we do the concept recognition. We said metamap and special processing for genes and proteins, and we could hook in here special processing for chemicals if you want to do special processing for anything, because many times areas of terminology have, we're going to say process government agencies. I mean, we would probably be a special section for doing that. And then constructing the predication itself, I'll point out how this works. So you get from what I call an indicator rule, some aspect of the syntax, like the verb treats, maps to the semantic relationship, the more abstract structure in the semantic network. It treats, you have to make that connection because other things mean treats besides just the verb itself, like in and for. I mean, aspirin for headache, radiology in breast cancer. So you have to work with that sort of thing. And then there are both syntactic constraints and semantic constraints, which we don't have time to go into the details, but you'll get a flavor of what they are in the example. So let's take this phrase. It's not really a complete sentence, but it doesn't matter because it does assert a complete proposition, as we'll see in a minute. So aggressive combination chemotherapy in the management of hypercalcemic renal failure. So the first thing we do is we assign parts of speech to them. Then we apply this syntax, which identifies each one of these as a noun phrase. Aggressive combination of chemotherapy in the management of hypercalcemic renal failure. And I consider if any of you don't read grammar, I consider prepositional phrases to just be a kind of a special kind of noun phrase that happens to be introduced by a preposition. So then this there's various ways of finding that aggressive combination chemotherapy. Its best match in the metathesaurus is combination drug therapy. So notice aggressive doesn't match. We say, well, it's only an adjective, so okay. And the chemotherapy and the drug therapy are listed as synonyms in the metathesaurus. So we know that they're the same thing. And it has, importantly, it has semantic type. It's a procedure.
And importantly, Thomas, you don't have to put combination chemotherapy as a synonym of drug therapy combination in the thesaurus.
No, well,
your system is able to map that.
Yes,
the synonym is not in the
yes.
thesaurus.
Yeah, that's right. It doesn't need to find this whole thing. It takes the pieces and puts them together, and it scores stuff to say, is this the best match?
That's a big added value.
Yeah. Metamap is pretty sophisticated, actually. It's pretty. It again has been in development. I mean, I actually was in it ground floor. It's been being developed for nearly 20 years. So, renal failure. We hear this maps directly. I think it is probably a synonym to kidney failure. No problem. It's a disease or syndrome. Now then, okay, we have the entities, the players in the drama. What are they doing in this little? It's kind of a little drama, right? So now we apply there are two things. I said there have to be syntactic constraints and semantic ones. Here we're going to find out that the indicator, is that so happens that nominalizations like management can indicate a relationship. If they do so, their arguments not only have to have the right semantic types, they have to be the right things for what management means, but they have to follow the rules of syntax of English for nominalizations. And I won't go into all of that, but it is sort of interesting that there's these. One of the rules is that the object can follow. Here's the object going to be the object. It can follow management if it begins with the preposition of. Now the subject can precede, but if the noun phrase that the nominalization occurs in begins with a preposition. So this, I just wanted to give you a flavor of the kinds of generalizations that, if you're willing to look for them, you can pull out about English and which are true. And we have a paper actually on this, on how to find arguments of nominalizations. So we say, okay, in this case, these two noun phrases are syntactically allowable to be arguments of management. What does it mean though? So, well, management, we have to have another set of rules that says management maps to treats in the semantic network. And we say ahead of time, even out of any sense, what are all the possible things that treats can mean? And it can mean all of these. I had to abbreviate these with pharmacologic substance, medical device, injury or poisoning down here, sign or symptom, anatomical abnormality. So these are the kind of things that can treat these kind of things. But in this context, since we already know that these are the arguments syntactically, then we can look and say, what semantic types do they have? And we match them up, and we say, oh, this has to mean therapeutic or preventive procedure treats disease or syndrome. So then we can say, what's the actual interpretation of it? We then just simply we substitute for these semantic types down here the actual concept, and that is what this English text means as a semantic triple in both the linguistic and the semantic web sense. So we do that for as much text as we want. As I said, we've done it for all of MEDLINE. We have about 56 million of these of the predication tokens. That is, we repeated, malaria. Malaria is transmitted by mosquito however many thousands of times. I think we have figured. I think we maybe have 8 million types of that. I don't remember if we've done it exactly right, but I think that's roughly that. And then 26 predicate types, that is, treats associated with, occurs with. And as I said, we have translated this, my colleague and actually boss, Olivia Goldenreiter, translated the RDF triple, so it's immediately accessible. Semantic Web, and he has something called the Biomedical Knowledge Repository, which includes, so he's translated the UMLS into these triples also, and our predication, so they're immediately, you can mix in that.
So the 56 million is, you have not done any collapsing of identical
No.
assertions.
No.
So that is really.
No, so therefore, everyone has its provenance. That is its. The UML, it has the PubMed ID and the sentence, the end sentence in the abstract that it occurred in.
So
But
what is really
you have collapsed in the sense that you just have the key sentences, the key triples, the three triples.
Well, we have it both ways. You go either way. You'll see right now.